Hey guys, welcome to the worked answers for the 2015 Day 1 MCAT exam paper. Let's get into it. So, question 1. We've been asked to expand these two brackets, x plus 2 times 4x minus 5. So we've got x plus 2 and 4x minus 5. So a fairly gentle expansion question here to start us off. We're going to multiply using the FOIL method. So we're going to say first, outer, inner, last. And so this looks like x times 4x is 4x squared. We've got x times negative 5 is negative 5x plus 8x, and 2 times negative 5 is minus 10. Okay, we're not fully simplified yet. We can collect like terms. We can add negative 5x and 8x. So we've got 4x squared. Negative 5 plus 8 is positive 3x and minus 10. Okay, expansion with simplification, 4x squared plus 3x minus 10 gets you the achieved here. Okay, moving on to question 2 now. Question 2b, that is. It says, give the x coordinates of the points where the graph of y equals x times x plus 3 cuts the x-axis. Okay, so we've got this function y equals, and let's just sort this out, y equals x times x plus 3. And we're looking for the x coordinates of the points where this graph cuts the x-axis, and that cutting the x-axis, that is the key information here. So let's just illustrate this first of all. We can draw a Cartesian graph, and cutting the x-axis, well, this is our x-axis here. At that point, y equals 0. Okay, so we can actually substitute y equals 0 into our equation. We can say 0 equals x times x plus 3. And so that means x equals 0 is one solution, and our second solution, x plus 3 equals 0, and therefore x equals minus 3. Okay, so here you've solved both values, x equals 0 and x equals to minus 3 will get you an achieved grade. Okay, moving on to question 1c now. Rani hired a bike for a ride. It cost $8 for 2 hours and then $3 for every additional hour. Her ride cost $23. So, and it says, how long did Rani hire the bike? So the first thing we can say is basically give ourselves a variable. We'd say h, and it equals number of hours. And so we're going to be forming some equations here. We just look through each piece of information and basically we're going to form an equation and solve for h, because the question is asking how long did Rani hire the bike. So looking at our first piece of information, it cost $8 for 2 hours. We can say that $8 is basically a flat rate, $8 for 2 hours. Okay, and then it says $3 for every additional hour. So let's say 8 plus 3h, but it's not just 3h, it's going to be 3h minus 2. And where does this come from? Well, if h is the number of hours and we're being charged $3 for every additional hour, that's the key word here, every additional hour, after those first 2 hours, then the $3 charge well, it says in the question, $3 only applies for third, fourth, fifth, and so on, okay? And that's where we get the h minus 2. So, last piece of information here, ride cost $23. That means we can say this equals the total, which is $23. So here we're just solving for h. We can bring our h to the right-hand side. We say 3h, 3 times h minus 2 equals 23 minus 8, which is 15. And we can divide by 3 on both sides. You can either expand these brackets or just divide by 3 straight away. So 15 over 3 is 5. And now solving for h equals, bring the 2 to the right-hand side, 5 plus 2 is 7. Okay, so here, correct equation set up and solved gets you the merit grade. And achieved is setting up equation omitting the minus 2 and solving. So let's say, for example, you said 8 plus 3h, 3h that is, equals 23. Okay, understandable, but it's a mistake, and that you will limit yourself to an achieved. Otherwise, equation given with the minus 2, so if you set up the correct equation, you would get an achieved here. Okay, let's move on to question 1D now. We've got this fraction, we've been asked to simplify it. 3ab squared minus 4a cubed b plus ab squared, and that's all over 4ab squared. So the first thing we'll do, as always, is just write down our expression. 3ab squared minus 4a cubed b plus ab squared, and this is all over 4ab squared. Okay, and we know at some point we're probably going to be factorizing, and then in all likelihood we'll have some common factors on the numerator and denominator, which we can cancel, and we'll simplify this way. But first, and this is always a good first step, is looking for any like terms. And so if we look at our denominator, we have ab squared, a cubed b, and a second ab squared. And so we can add our ab squareds. Okay, we've got 3ab squared plus ab squared. And so before we do any factoring, cancelling, let's add the like terms in our numerator. So it becomes 4ab squared minus 4a cubed b. Okay, and this is all over, again, 4ab squared. And at this point, we will look to factorize. Common factors in the numerator, we have 4a and b, and inside the brackets, b minus a squared. And this is over 4ab squared. Okay, we look to common factors on the top and bottom now, and we can see straight away we can cancel 4, we can cancel a and b on the numerator and the power of 2 in the denominator, and so we're left with a fraction b minus a squared over just single b. Now the marking schedule mentions 1 minus a squared over b, and basically these two fractions are can both be considered simplified. Okay, on the second one there, you've got b over b, and that so it simplifies to 1. But both answers are accepted here, and so rational expression simplified gets you the merit. your achieved comes from simplifying or factorizing the numerator. So I want to say this step here we're getting achieved. Definitely our second step gets you the achieved. Okay, let's move on to question 1E now. Question says, Sam and Jake live 8 kilometres from each other. Sam skates 10 kilometres in the same time as Jake rides his bike 15 kilometres. If they both leave home at the same time and travel towards each other, how far from Jake's home will they meet? Okay, so again we're going to be setting up some equations here. The first thing we can do is draw a bit of an illustration. So let's say this is Sam's house and this is Jake's house. And we know that there is an 8 kilometre distance because it says Sam and Jake live 8 kilometres from each other. So this distance here is 8 kilometres. And so forgetting about speeds, so forgetting about that second line of information, let's just say some hypotheticals here. Jake, for example, because we know they both leave home at the same time and travel towards each other. Jake might travel this distance, let's say it is 3 kilometres. And so that would mean Sam has travelled 5 kilometres. Similarly, Jake might have travelled 4 kilometres, and so Sam would also have travelled 4 kilometres. Okay, in any case, our first equation is going to be, based on this information, it's going to be S plus J equals 8. And we've just proven that here. Okay, thinking about our second equation, we have to look, now we look at our second line of information. Sam skateboards 10 kilometres in the same time as Jake rides his bike 15 kilometres. So let's say S equals 10. And let's say Jake is 15. Now, if we want them to equal each other, and it's implied in the question, because we're talking about when will they meet, if we want them to equal each other, we basically have to multiply S by 15 and J by 10. Okay, so we can say 15S equals 10J. And if you were to substitute our numbers, S equals 10 and J equals 15 in, you would find that indeed the equation is true. Okay, we could also say, we could divide by 10 on both sides and say 1.5 S equals J. And if I was to just prove this for a second, we could draw a bit of a table. We've got S and J. S is 10, J is 15. And so what's the multiple here? It's times 1.5. Okay. So 1.5 you multiply by, S you multiply by 1.5 and that equals J. Okay. So we've got 3 equations here, but really 2. We're going to use S plus J equals 8. And you could use either 15S equals 10J or 1.5S equals J. Let's use 1.5S equals J, because we know at this point we're going to be using simultaneous equations here. You could use the elimination method, but we've got, we already have a value for J, 1.5S, so we can say S plus, and instead of writing J, we can say 1.5S, we substitute that value in, and that equals 8 here. Now there's an invisible 1 in front of the first S, and so we collect like terms. We come out with 2.5 S equals 8, and so s must equal 8 over 2.5, and now that I look at it, that's not an easy calculation, remembering that there's no calculators in the MCAT exam. We could say 8 divided by 5 over 2, because that's equivalent to 2.5. We could say 8 times, and flip the fraction, 2 over 5. That would equal 16 over 5. And still we haven't made it any easier for ourselves. I'm just trying to basically work out 8 over 2.5. So we could actually split this fraction here. So 16 over 5 is split into two parts. 5 over 15 plus 1 over 5. And at this point, we can simplify, and 15 over 5 is 3 plus 1 over 5, 0.2, so that becomes 3.2. Okay, and that's a value for s, so s equals 3.2. Now, thinking back to the context of the question, we're looking for the distance from Jake's house when they meet. So when they meet, s equals 3.2. And if we take it back to our little diagram here, instead of 5, we can say s is 3.2, and therefore, according to our equation, s plus j equals 8, j must equal 8 minus 3.2, which is 4.8. Okay, so how far from Jake's home will they meet? Well, they meet 4.8 kilometers from Jake's home. So, for this question, correct algebraic expression leading to the correct solution gets you the excellence grade here. So 4.8 is the excellence. Your merit comes from combining the equation into one variable, so that's your simultaneous equations work. So one variable, we can see this step here. Your achieved is one equation formed, so one equation formed. In all likelihood, you probably formed the s plus j equals 8 equation first. Other than that, either of these two equations would also get the achieved. Okay, let's move on to question 1F now. It says Danny is trying to find a value for c so that x squared plus 6x plus c equals 0 has only one solution for x. Find the value for c and the solution to the equation. Okay, so we've got this equation here, x squared plus 6x plus c equals 0, and we're looking for c and the solution to the equation. The important thing to understand in this question is this information here, as only one solution for x. If we were to draw this situation, again we've got our graph, and one solution for x means one root. And so we've got a parabola, it's a positive parabola, and so it touches the x-axis only once. Okay? Now that's opposed to, let's say, normal quadratics where you have two roots, so crosses over the x-axis twice. So here would be your two roots, but in our situation we have one solution for x, so this is your solution here. Okay, and so if we think about factorizing this quadratic, instead of having two sets of brackets equaling 0, we're going to have one set of brackets, and so they're going to be raised to the power of 2 and equaling 0. Now what goes inside these brackets? Well, you know, we've got x, and we're after a value. Let's just plug in a variable, so let's say plus a, and we can actually expand these brackets here. We can say x squared, and the b term is 2ab, so plus 2xa, and then plus a squared, and that equals 0. Okay, and so at this point, let's compare equations here. So we know we've got x squareds. We have 6x and 2xa. And we've got c and a squared. And basically, the corresponding colours equal each other. Okay, so we could say, for example, green equals green. And so we could say 2xa equals 6x. Now, our x's cancel. We're left with 2a equals 6, and therefore a equals 6 over 2, which is 3. Likewise, we could say orange or yellow. Yellow equals yellow. Okay, so it becomes a squared equals c, and we have a value for a. It's 3, so 3 squared equals c, and therefore c equals 9. And we can say that this is true, all of this theory here, with our x plus a all squared theoretical factorized quadratic 4-1 solution. Okay, at this point, we have our value for c, and we're looking for the solution to the equation. So let's go ahead and just write out our equation again. X squared plus 6x. Instead of writing c, let's use 9, and this equals 0. Okay, so we can factorize, and in fact we already know what our factorization is going to look like. Again, it's this x plus a all squared, and we have a equals 3. But let's factorize the conventional way. We're looking for two numbers that multiply to the c term, which is 9, and the same two numbers that equal the b term, which is 6. And we know that yes, those two numbers are 3 and 3. So we're going to say x plus 3 all squared equals 0. Now, some of you, if you're familiar with perfect square or completing the square equations, you would have straight away gone b over 2, so half b, and that looks like 6 over 2 equals 3. And you would have plugged it into your equation. Okay, we've proven it basically 3 ways here. The a term in this case is 3. And so if we're looking for the solution to the equation, x plus 3 equals to 0, and therefore x equals -3. Okay, so for this question, value of the constant found and the equation solved gets you an excellence grade. Your merit, value of constant found, or solution from perfect square without giving the value of the constant. So I think they're sort of getting at an either or situation. So value of constant found or solution from the perfect square. Let's just say your merit is here, c equals 9. And possibly you've made some progress with this x plus 3 all squared. Your achieved is factorizing as a perfect square as an indication of understanding the meaning of one solution. Understanding the meaning of one solution. So that is, I think all of this theory work, our graphs, our theoretical equation, that should get you an achieved. Okay, let's move on to question 2 now. Question 2a, we've been asked to factorize this quadratic, 3x squared minus 11x plus 6. So 3x squared minus 11x plus 6. Now this quadratic is interesting in that the a term, so when I say that, a quadratic is written in the form ax squared plus bx plus c. The a term in this case is greater than 1. Okay, it's 3. And so that means the first thing we do here is multiply a by c. So 3 times 6 equals 18. And therefore we're looking for two numbers that multiply to this number 18, and two numbers that add to the b term, which is minus 11. And those two numbers are minus 9 and minus 2. So we can say 3x squared. And now we split the b term into two parts, minus 9x minus 2x plus 6. Okay, we split the whole expression into two parts here. And possibly we should just highlight this. Minus 11x, we haven't actually changed anything. We've just turned it into minus 9x minus 2x. Okay. Anyways, continuing on, we've got basically a left-hand side and a right-hand side. We factorize the left-hand side, 3x and x minus 3 is inside the brackets, minus 2 and x minus 3. And you know you're on the right track when those two brackets are the same. We're not quite finished. We can further simplify and say 3x minus 2 becomes a factor, and we've got x minus 3. Okay, so for here, correct factorization, 3x minus 2 times x minus 3 gets you the achieved here. Question 2b now. A swing is made by attaching two ends of a rope to two different points on a steel frame. The height h meters of the rope above the ground at a distance x meters from the left hand side of the frame is modelled by this equation, h equals 2x times x minus 1.5 plus 1. What is the height above ground of the point on the rope where x equals 2? So we've got this diagram here. We've got x and h. Basically, none of that matters. This is just a long-winded way of saying what is the value of h when x equals 2. So we have this equation for h, 2x times x minus 1.5 plus 1. And we know, because we're asking for the height above the ground on the rope where x equals 2, in this case x equals 2, we're going to substitute 2 into our equation wherever x features. So this looks like h equals 2 times 2 times 2 minus 1.5 and plus 1. Simplifying, we've got 4 inside the brackets. 2 minus 1.5 is 0.5. And this is still being multiplied. And plus 1. So 4 times 0.5 is just half of 4. So it becomes 2 plus 1. And that equals 3. Okay, h equals 3. You've substituted and given the correct solution. For this, you get an achieved here. So, moving on to question 2c now. It says, if y equals x squared plus 3x minus 10, for what values of x will y be negative? So we've got this function y equals x squared plus 3x minus 10. And we're looking for values of x when y is negative. The y is for what values of x will y be negative? That's the key part to the question. Basically, they're saying when does or is y less than 0 here. And so we have an equation for y. It's x squared plus 3x minus 10. And we're going to set that less than 0. Okay, let's go ahead and factorize this quadratic. X. Basically, we're looking for two numbers that multiply to minus 10 and add to positive 3. Those two numbers are positive 5 and minus 2. So we've got x plus 5 and x minus 2. And this is less than 0. Let's assume for a moment that our quadratic equaled 0. So we could say x plus 5 equals 0, and therefore x equals negative 5. We could also say x minus 2 equals 0, and therefore x equals positive 2. Okay, but that's not the case. We have this less than or equal to, just less than 0. And so we have to go a step further. Let's draw this quadratic. It's a parabola, a positive parabola. And we can draw our x-axis because, like we said in the earlier question, where it cuts the x-axis, rather everything below the x-axis, satisfies our inequality here. So this is y equals 0, and therefore everything below y equals 0 those are our required, well, that's the required region, and so we're looking for the corresponding x values, is the best way to put it. Now, we said our roots basically are x equals negative 5, so this is negative 5 in here, and positive 2. We're looking for basically all the values for x between negative 5 and positive 2. Okay, that is the key to this question. Now, it's a pretty small interval. We could list them out, right? Negative 4, negative 3, negative 2, 1. Sorry, 0 and 1. And did I say negative 1? I'm not sure. Anyway, that wouldn't be feasible if we were working for with a massive range of values. And so what we say here is x doesn't equal negative 2 or negative 5. X is less than 2, and x is greater than negative 5. Okay, this could be written as x is less than 2 or greater than negative 5. And here, this interval gets you the merit here. Your achieved grade is factorizing the expression written, so achieved at this point here. The marking schedule also mentions achieved for including the endpoints in the inequality. So possibly you said x is less than 2 and greater than -5. Now that's not true because the original question said less than 0. So that would not be correct, and you would limit yourself to an achieved here. Anyways, moving on to question 2D now. It says, Cherie has had an operation and needs to build up her strength by walking. She slowly increases the time for which she walks. She wants to increase the time for which she walks to 160 minutes each day. The first week, she goes for a 10-minute walk each day. Each Monday, she doubles the time for which she walks each day. The time for which she walks each day in week N can be modeled by the equation. And so after all of that, they've given us this equation, t equals 10 times 2 to the power of n minus 1. Now, the question is asking how many weeks will it take her to reach her goal of walking for 160 minutes a day. So let's just define some variables first of all. We've got t, and that equals, at first I thought that equals number of weeks, but that actually equals minutes here. So time in minutes. Now n, that is, we can also call that time, but here it's in weeks. Okay, so we've got this equation, t equals 10 times 2 to the power of n minus 1. And what are they asking us to do? Well, we're looking for how many weeks, so basically we're solving for n, will it take her to reach her goal of walking for 160 minutes a day. And when Cherie is walking for 160 minutes a day, t will equal 160. And so we can substitute that into our equation. 160 equals 10 times 2 to the power of n minus 1. Divide by 10 on both sides, we've got 16 equals 2 to the power of n minus 1. And at this point, possibly you're a little bit stumped as to what to do next. And so basically you do these questions and it's just recognizing that it is an indices question, and so we want to write everything with the same base here. What I mean by that is saying writing everything in base 2. So we can list our powers of 2 here. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and 2 to the power of 4 equals 2, 4, 8, and 2 to the power of 4 equals 16. And so we are going to substitute 2 to the power of 4 into our equation. Yeah, so as I said, this is a classic MCAT question, and it helps to go into the exam knowing your powers of numbers. So powers of 1, no, well, that's a given. Powers of 2, 3, 4, 5, and even 6. Okay, so now we've got this equation, 2 to the power of 4 equals 2 to the power of n minus 1. Knowing our indices rules, if we've got terms that equal each other, they have the same base, we can cancel the base, and we can say the indices, or the powers that they're raised to, must also equal each other. So 4 equals n minus 1, solving for n equals 5 here. And with that, we've got our correct answer. It's probably best to write a bit of a statement. So they're asking for how many weeks will it take her to reach her goal. We can say in the 5th week. The marking schedule also mentions saying, they say, or after the 4th week, okay? Because it is true that it's not just the 5th week. If Cherie is always increasing her time for which she walks, well, it's going to be everything after that 4th week. Okay, so n equals 5 here gets you the merit grade. Your achieved is simplifying the equation. So this step here gets you the achieved. The marking schedule mentions simplifies equation or inequations. So they have said 2 to the power of n minus 1 is greater than or equal to 16. And it's sort of hard to see why they would say that, as opposed to just equaling. And I guess we just come back to this idea that Cherie is always increasing her time, and possibly the question, with the way it's worded, it's not necessarily saying when is the first time she's walking for 160 minutes. It's how many weeks will it take her to reach her goal. Okay, so possibly I've just contradicted myself there. Anyways, it's something along those lines is the reason why they've gone with greater than or equal to. Either way here, n equals 5 is your final answer. Okay, moving on. And we will move on to question 2e here. It says Tane is asked to solve the equation x squared minus 1 all over x squared plus 2x plus 1 equals 3/4. Okay. Bit of a different question here. It says Tane's solution is given below, and they've actually given us his working. Tane's teacher tells him he is wrong as it has only one solution. Explain Tane's mistake. Okay, so yeah, not a whole lot of room here. Let's basically look at Tane's working and decide where the mistake is. And we could even just number each line of working here. Okay, looking at line 1, basically he's just cross-multiplied, and that looks all fine. Line 2, he's expanded his brackets on both sides. Again, that looks fine. Line 3, I believe, is where the issue is. So let's copy out line 2 first of all. 4x squared minus 4 equals 3x squared plus 6x plus 3. And so if we were looking to bring everything to one side, putting it into ax squared plus bx plus c form, which is what Tane has done here, we'd bring everything to the left-hand side, and so we'd go 4x squared minus 3x squared equals x squared. Positive 6x becomes negative 6x, and minus 4 minus 3 becomes minus 7, and that all equals to 0. And so if we compare our two equations here, the difference is, of course, this positive 6x. And so we can say positive 6x is wrong, or incorrect, or whatever you want to say. It should be, let's say it should be negative 6x. Now we're not quite done here. Looking at the question, Tane's teacher tells him he is wrong as it has only one valid solution. Note the wording of that question. He's wrong because it has only one valid solution, not because he's written 6x instead of minus 6x. Okay, basically, let's go ahead and factorize our correct equation. We'll solve for x, and we'll see what's going on here with this only one solution. So I've got x squared minus 6x minus 7, and this equals 0. We're looking for two numbers that multiply to minus 7 and add to the b term, which is minus 6. Those two numbers are positive 1 and minus 7. So we've got x plus 1 and x minus 7. This equals 0. Therefore, x equals minus 1 and 7. Okay, and we've still got two solutions here. Tane's teacher says it has only one valid solution. Basically, I'm just going to go ahead and read the marking schedule here. It says x equals to negative 1 is an invalid solution as dividing by 0. What do they mean by that? X equals to negative 1 is an invalid solution because dividing by 0. Well, let's look at our original equation here. And if we're dividing by 0, let's look at the denominator of the left-hand side. Obviously, the right-hand side we know is 3/4. We're not dividing by 0 there. X squared plus 2x plus 1. If we were to substitute x equals to negative 1 in, we would have negative 1 squared plus 2 times negative 1 plus 1. And this would equal, negative 1 squared is just 1 minus 2 plus 1. And you can see here that this simplifies down to 0. Okay, we know that we do not want to be dividing by 0. And so that is why, in this case, x equals to negative 1 is an invalid solution. So we can say x does not equal negative 1. Invalid because dividing by 0. Thinking about our second solution for x, 7, well, we just need to look at it, and we know that we won't be dividing by 0 here. You will have a denominator, and so x, only solution therefore, is x equals to 7. Okay, so here you've got an excellence question, and you get your excellence from elimination of one solution as x equals negative 1 is invalid, and you've also given a justification. This would get you an excellence grade here. Your merit is correct factorizing and solving, giving two solutions, so x equals to negative 1 and 7. Getting up to that stage gets you a merit, or substituting the given solutions and finding one of them does not work. So again, you can get a merit from our sort of discussion up here around the negative 1 would also get a merit. Your achieved is identifying the positive 6x would get you an achieved in this case. So there we have it. Moving on to question 2F now. It says a group of people go to a fun park. There are 38 in the group. The cost for a student is $10. Cost for an adult is $12. And the total cost for the group is $420. And the question asks, how many students were in the group? So let's just come up with some variables first of all. We can say S is the number of students. students, and likewise A is the number of adults here. And so we're going to be forming some equations, and we just have to work through each piece of information methodically. So looking at our first piece of information, there are 38 in the group. That means S plus A equals 38. Okay, thinking in terms of money now, this is our pieces of information 2, 3, and 4. Cost for a student is $10, so we have 10 times S. Cost of an adult is $12, so this is 12A. And the total cost for the group is $420. Okay, so again, we're going to be solving simultaneously. We're looking for, obviously, how many students are in the group. And we can use the elimination method. We've got this pretty nice equation, S plus A equals 38. And so let's rearrange it and say S equals 38 minus A. Okay, that means we can say 10, and substituting for S, 38, not 38A, but rather 38 minus A, plus 12A equals 420 here. So, expanding our brackets, we've got 10 times 38 is 380, minus 10A, plus 12A, and that equals 420. So we can make A the subject. We're looking to solve for A. We'll bring 380 to the right hand side. Minus 10A plus 12A is 2A. And this equals 420 minus 380, which is 40. Okay, divide by A on both sides. 40 over 2 equals 20. So we have the number of adults in the group, that's 20. We're looking for the number of students, and according to our equation, the number of students can be found by saying S equals 38 minus the number of adults. And so 38 minus 20 here. And so that means there must be 18 students in the group. Okay, here, solution found gets you an excellence. Your merit is one variable eliminated, so this step here, we eliminated S. And your achieved is one equation formed, so these are our two equations. You probably did S plus A equals 38 first, that gets you an achieved. If not, 10S plus 12A equals 420 also gets the achieved. Okay, and that's us for question 2. Let's move on to question 3 now. And so question 3a, Jake thinks of a number, adds 5 and multiplies the result by 4. He gets an answer of 24. Find the number Jake was thinking of. Well, we need to decide on a variable for our unknown number. Let's just use x. And so the first piece of information, Jake thinks of a number, adds 5. So we've got x plus 5. And it then says he multiplies the result by 4. So x plus 5, and he multiplies this whole result by 4. Okay, so we write it like this. And this equals 24 because it says he gets an answer of 24. Okay, so we're trying to find the number Jake was thinking of, meaning we're solving for x. Let's divide by 4 on both sides. 24 over 4 is 6. and so x equals 6 minus 5, which is 1. So a pretty simple achieved question here to get us started with question 3. X equals 1 gets you the achieved. Okay, moving on to question 3b. It says a rectangular garden is n meters wide. Its length is 2 meters longer than its width. Find a formula for the area of the garden in terms of n. So we can draw this. We've got a rectangle, and it says it's n meters wide. So n is the width, and its length is 2 meters longer than its width. So we can say its length is its width plus 2, so n plus 2. And we're looking for a formula for the area in terms of n. Now, the area of a rectangle is, of course, base times height. And so all we need to do is substitute in our base and our height. Let's say the base is n. It doesn't matter, we're multiplying, so it doesn't matter which way round you multiply. N is our base, and therefore our height is n plus 2. Now, does the marking schedule want us to expand? No, it doesn't. Area equals n times n plus 2 gets you the achieved grade here. Okay, let's move on. And by the way, marking schedule mentions expression correct with brackets or an expanded form. Okay, so moving on to question 3c. 5 people on a camp have a stomach bug. The bug spreads at a constant rate r. At the end of 3 days, 320 people have the bug. This can be multiplied by 320 equals 5r is our equation. 5r to the power of 3, that is. And it says find the rate r at which the bug is spreading. So they're just asking us to solve for r here. So we're looking to make r the subject. Okay, the first thing we can do is multiply by 5 on both sides. Now, 320 over 5 is not a basic fact. Basically, let's say we can do it in parts, right? 100 over 5 is 20, meaning 300 over 5 is 60, and 20 over 5, 20 being the remainder, is 4. So we've got 320 over 5 is 64. That equals r cubed. And what's the opposite of cubing something? Well, to get r on its own, we're going to be cube rooting. 64 equals r, and therefore r equals not 8, but 4 here. R equals 4 gets you actually a merit here. And achieved is equation simplified, so our first step of working should get an achieved. Okay, moving on to question 3D now. It says Sarah and Marie are studying for the NCEA exams. Sarah claims she does more study than Marie. Marie says she does 3 hours study on each of the 4 days during the week. Sarah says she studies for 2/3 of that time during the week, and at least a further 2 hours on the weekend. Is Sarah's claim always correct? First of all, what is her claim? Well, she claims she does more study than Marie. So let's say S, meaning Sarah, is greater than Marie. Greater than M, of course, which represents Marie. Okay. So we need to work through this information here. If Marie says she does 3 hours study on each of the 4 days during the week, so M equals 3 hours of study times 4 days. And so Marie does 12 hours of study. Sarah is a little bit more complicated. She says she studies for 2/3 of that time during the week. So we can say she studies for 2/3 of 12. And at least a further 2 hours on the weekend. At least a further 2 hours on the weekend. Let's say plus 2. And they're wondering whether Sarah's claim is always correct. Well, let's just simplify the equation for Sarah here. 2 times 12 is 24, over 3 is 8, plus 2, and that equals 10. So Sarah does 10 hours. Now that is not more than Marie's 12. And so what do we say about that? Well, the marking schedule sets it out. Basically, you've got 3 conditions. And I'm just going to sort of use the marking schedule here to get across what they are saying. Condition 1, so they've got 3 conditions. Condition 1, they say if Sarah studies for more than 4 hours on the weekend, she studies for longer than Marie. So let's write that and then we can explain it. If S studies for more than 4 hours, let's just say greater than 4 on the weekend, S is greater than M, okay? And why is that true when Sarah studies more than 4 hours on the weekend? And how is that even possible when she stays, well, she doesn't say she studies for 2 hours on the weekend. The key to this question is Sarah says she studies for at least a further 2 hours on the weekend, okay? And so that means it can be more than 2 hours, obviously. And so the marking schedule actually mentions S doesn't necessarily equal 10. S is always greater than or equal to 10, not less than 10, because the 2/3 of 12 is constant, and if it's at least a further 2 hours, that means 2 hours or more. So Sarah's equation is actually an inequation, and it's set up like this: greater than or equal to 10, with the hours studies on the weekend basically being the variable. Again, this 2/3 of 12 is, we can say that's constant because it's based on Marie, and Marie's hours are constant. Okay. So, that's condition 1. Condition 2, they say if Sarah studies for 4 hours, so S equals 4 on the weekend, they study for the same length of time, so S equals M. And that makes sense. Let's say Sarah studied for 4 hours on the weekend and not 2. That would mean S is greater than or equal to, well, it's equal to, in this case, 8 plus 4, and therefore it's equal to 12, and that, of course, is the same as Marie. Okay? That's condition 2. Condition 3 now. If Sarah studies between 2 and 4 hours on the weekend, so S let's say equals between 2 and 4 on the weekend, then she studies less than Marie. S is less than Marie. And that's also true, and that's what we were getting at basically in our first scenario there, where she studied for 2 hours on the weekend, and that ended up making for 10 hours in total, and that's less than Marie, obviously. It says between 2 and 4 because, as mentioned, it's at least 2 hours on the weekend, and 4 is the other limit, because if she goes over 4, according to condition 1, then she's studying for more or for a longer time than Marie. Okay, I hope that makes sense. You can, and it probably would be more beneficial to you in this case, just to go have a look at the marking schedule, because there's not much maths involved. It's just a lot of basically looking at the numbers and playing around with them. Anyways, complete response with an inequality in both scenarios here gets you the excellence. So all this work gets you an excellence. Your merit is inequality and one of the statements. So let's say one of the conditions. Let's just say the first one. That would get your merit. And your achieved is an algebraic inequality. So just setting up the inequality gets you an achieved. Let's say this step here gets you an achieved. Okay, let's move on. And let's move on to question 3E now. It says, Sammy and Marius earn pocket money by working in a garden. Marius earns $14 an hour. Sammy earns $4 an hour more than Marius. Marius works twice as long as Sammy. Together they earn a total of $138. How much does Sammy earn? So it must be the second or third question of this sort in this paper. It's going to look like possibly it'll be a simultaneous equations question. And again, we're looking for how much does Sammy earn. Okay, defining some variables. Let's say S is Sammy and M is Marius. Okay, and so we know that Marius earns $14 an hour, so we can say M equals basically 14 an hour. Should we say, just thinking about how to write this, we can't quite say M equals 14M, but I do want to use S and M as representing the hours of each of them. Let's just forget the M equals, and let's say 14M. Okay, these are in terms of hours. Now, Sammy earns $4 an hour more than Marius. Okay, so they are going to earn 4 plus 14 is 18. 18S. And if Marius works twice as long as Sammy, then we can say for them to be equal, M must equal 2S. Okay, I hope this is all making sense. Lastly, together they earn a total of $138, meaning 14M plus 18S equals the total $138. Okay, so we've got two equations here. We can substitute. This is similar to the Sam and Jake question. We can substitute m equals 2s into our equation. And so we can say 14 times 2s plus 18s equals 138. 14 times 2 is 28s plus 18s equals 138. Collecting like terms, 28 plus 18 is 46s, and this equals 138. And so this is something we just have to go ahead and work out. 138 over 46. At this point, you're hoping, praying that this is a whole number value for s. So 138 over 46. The best way to do it probably in this case is just by counting up in 46s. And so 46, that's our first. Second is going to be 92. And third, 92 plus 46. Well, 92 plus 40 is 132, plus 6 is 138. Okay, so it's going to be 3 hours worked for Sammy. S equals 3 hours worked. We're looking for how much does Sammy earn. If Sammy works 3 hours, how much does he earn? He earns $18 an hour. So 3 times 18 equals $54 here. Okay. And so here, problem solved. Sammy works for 3 hours and earns $54, gets you the excellence grade. Your merit is relationship formed in one variable or problem solved for the other person. So we ended up solving for Sammy straight away. We didn't find the hours for Marius. So it's that first part, relationship formed in one variable. And so that's going to be this step here. Gets you a merit. And your achieved is one equation given. So either m equals 2s gets you an achieved, or 14m plus 8s also gets you the achieved. Okay. Let's move on to the final question of the paper, question 3F. It says the volume of a cylinder is given by V equals pi r squared height, and that of a cone is given by V equals pi over 3 r squared height. A cylinder has the same radius as the base of a cone. If the volume of the cylinder is twice that of the cone, give an expression for the ratio of the height of the cylinder to the height of the cone. Okay, so it feels like a fairly complicated sort of question. The first thing to understand is that in this case, the volume of the cylinder is twice that of the cone. And so we can say we want to equate the volume of the cylinder and the volume of the cone. Basically, we can say volume of the cylinder equals 2 times the volume of the cone here. Okay, and so now let's substitute in some values. We have the equations for volume of a cylinder and volume of a cone. We've got pi r squared h equals 2 times pi over 3 r squared h. Okay, so let's just simplify here. Pi r squared equals 2 times a third is just 2 over 3 pi r squared h. Okay, we can cancel the r squareds, and we know we can do this. I think we're allowed to do this because it says a cylinder has the same radius as the base of a cone. I think that's what they're getting at with that information. That is what allows us to cancel our squareds here. We can also cancel pi because pi is a constant. It's being multiplied on both sides. We can cancel that. And so we're left with h. And at this point, we're talking about denoting some variables. Let's say the radiuses, or the radii, might have been the same, but the height of the cylinder and the cone respectively are not equal. So this is h of the cylinder equals 2/3 the height of the cone. And I think with that, we can't go any further in terms of maths. And so, thinking back to the context of the question, we're looking for a given expression for the ratio of the height of the cylinder to the height of the cone. And so what is our ratio? Basically, ratio of the height of the cylinder is 2/3. H of the cylinder equals 2/3 h of the cone. And so the marking schedule also gives it as in proper ratio form 2:3. To be honest, which way you state it, so 2:3 or 3:2, 3:2 is not correct, but the marking schedule says accept 3:2. They say relationship simplified, ignore if the relationship is stated as 3:2. And to be honest, this is not something I've looked at, or should I say thought about ratios in a long time. Anyway, you get an excellence for this question here. So excellence grade. Your merit is possibly you've made an error in the simplification or consistent solution with the multiplication factor on the wrong side of the relationship. So merit, they're just talking about errors here. Error in the simplification. Let's say this is your merit. Your achieved is relationship formed for the volumes. So our first step here, just stating this relationship gets you an achieved. Okay, and that is us for the 2015 MCAT. I hope you enjoyed. Yep, that was our last question. As always, thank you all for watching, and feel free to chuck any questions or comments in the comment section below. And I'll see you next time. Cheers.